Okay, we begin the process of doing operations with radicals. In other words, adding, subtracting, multiplying, and dividing radicals. In this video here, we're going to combine the like radicals. And by the way, this is a handout that was given in class on Wednesday. If you didn't get a copy, you can get one off of the My Math Lab. So we start with some very easy examples, and then we'll work our way up. Remember, like in like terms, when in dealing with terms, you're only allowed to combine like terms. Same thing with radicals. You're only going to be able to combine like radicals. So let's take a look at the first example, which is relatively simple here. Notice that all three of these radicals are like radicals. They have the same radicand, 3, and the index for all of them are 2, since all of them are square roots. So the way we combine the like radicals is just like we combine the like terms. What we'll do, we'll put some parentheses here, and we'll just put all the coefficients inside. Parentheses 6, take away 9, plus 2. And then I'll multiply this by the common radical, which is square root of 3. And now, again, just add these numbers inside the parentheses. 6 plus 2 is 8. Subtract 9 gives me a negative 1 times radical 3. But negative 1 times any quantity just makes the quantity negative. So there's no need to write the 1. We'll just write it as negative square root of 3. That's the first example. Now, let's take a look at the second example. In the second example, what we notice is that there's some radicals that are like radicals and some that aren't. For example, the first radical is like the third radical, so I'll single underscore those. The second radical, I'll double underscore it, is like the fourth one over here. So we'll do this exact same thing we do with the like terms. What we'll do, we'll add the coefficients of the two radicals that have a radicand of 5. Notice that the first coefficient is 7. The other one is negative 4. Since the signs are different, we subtract. 7 take away 4 gives me 3. And then I put my common radical, which is radical 5. Now, looking at the two radicals that have a radicand of 2, this one here and this one here, notice that the signs are both the same. When the signs are the same, we add the coefficients keeping the common sign. So I got an 8, and notice that there is not a coefficient shown here explicitly, so it's understood to be 1. So that gives me a total of 9 radical 2. Now, this expression right here is in simplest form. It cannot be simplified any further. Remember, you're only allowed to combine like radicals. So just to drive that point home, just a reminder here, if I were to take radical 5 and subtract from that radical 2 and say, oh, I'm sorry, that should have been a radical 2 here. I cannot subtract the radicands, 5 take away 2 and get 3. That is a big no-no. You cannot combine radical 5 and radical 2 because they are not like radicals. For that reason, up here, I cannot combine 3 radical 5 and 9 radical 2. These are not like radicals, so that answer right there is in simplest form. Okay, let's go on to the next example. If you look at these two radicals in example 3, you might think, well, look, they're not like radicals because the radicands are different. But the problem here is that neither one of these radicals is in simplest form. I'll let you fill the details in here. 54, if I do a prime factorization on 54, 54 ends up having one factor of 2, and it has three factors of 3. Similarly, if you do a prime factorization on 16, you will see that 16 can be written as 2 raised to the fourth power. Now that both radicals, the radicands, are written in this form, you can see that this first radical needs to be simplified since this exponent is not less than the index of 3. So what I do, I take the index, divide it into the exponent, goes in one time. So that brings out one factor of 3. The exponent of the 2 is a 1, and that's less than the index. So the 2 stays underneath the radical. Similarly, the next one, I use my shortcut for simplifying radicals. I divide the index 3 here, into the index 4. I'm sorry, into the exponent 4. Well, 3 goes into 4 one time, so that means that brings out one factor of 2, and the remainder is 1, so that leaves one factor of 2 underneath the radical. Now look at the two radicals. Notice that the two indices are the same. The radicands are the same. So that means that I can combine these. These are like radicals. And then all I do is take this 3 and I subtract that coefficient of 2. And that gives me a 1 times the cube root of 2. However, as before, if the coefficient is 1, there's no need to write it. So the answer is just the cube root of 2. Okay, now let's go on to the next example here. The next example is a little bit more complicated. Notice that all three of these radicands, 32, 50, and 8, um, and since I'm dealing with square roots, all of these radicals can be simplified. So I use a shortcut for simplifying square roots. What I do, I take the 32 and I try to write it as a product of two numbers where one of them is the largest perfect square factor of 32, which in this case turns out to be 16. 16 times 2 is 32. Similarly, for the 50, the largest perfect square factor of 50 is 25, and for the 8, the largest perfect square factor is 4. Now let's go back to the first radical. I got 7 times the square root of 16 times 2. I can use property R3, the multiplicative property for radicals, and I can break this up as the square root of 16 times the square root of 2. Actually, 7 times radical 16 times radical 2. And we all know that the square root of 16 turns out to be 4. Notice I put parentheses around here. I have 7 now, and then in parentheses, I got 4 radical 2. Similarly, on the next one, I got 6 here, and then inside the parentheses, I simplify radical 25, which is 5, and the 2 stays underneath the radical. So I got 5 radical 2 in the parentheses. On the next one, the square root of 4 is 2, and I got this 2 that's underneath the radical. Well, if you look at these three radicals, well, first let's go ahead and multiply the 7 and the 4. That gives me a 28 radical 2. I go the 6 times the 5, gives me a 30 radical 2, and this one just comes down as 2. If you look at this line right here, these three radicals are like radicals. So I use parentheses now, and all I do is put all the coefficients. The 28, the negative 30, and the positive 2. So when I add up these three numbers, notice that 28 minus 30 plus 2 adds up to 0. So I got 0 times radical 2. So the answer just turns out to be 0. Wow. Another way of writing 0 using these radicals. Now, the last example looks kind of complicated, but it really isn't if you know how to simplify the radicals using the shortcut method. First of all, I want to point out to you that this first radical needs to be simplified. Why? Because look at the exponent of the x. It's 4, that's greater than the index of 3. If you look at the second one, both exponents of the radicand factors, x and y, are less than the index, so I don't have to simplify this second one right in here. On the third one, notice that the 7 is greater than the index of 3. So we do our little shortcut, divide the index into that larger exponent. So on this first one, I still have this factor of x comes out front, and now I divide the 3 into the 4. 3 goes into 4 one time. That brings out one factor of x. The remainder, when I divide 3 into 4, is 1, so one factor of x stays underneath. This y stays underneath the radical. So then I take this x here and this x and multiply them, and that gives me an x squared cube root of xy. Now, the second radical over here, there's nothing to do with that. It's already in its simplest form since both of these exponents are less than the index. So I just bring it down as 3x squared cube root of xy. Now, on the third one, notice how I got an x here. So I put the x, and then I put parentheses, and I simplify this radical up here. Divide the 3 into the 7, goes in twice. Look at the base is y, so 2 factors of y come out. So I got a y squared. When 3 divides into 7, the remainder is 1. So there's only one factor of y left underneath the radical. So I'll take this x times that y squared to get rid of the parentheses and get xy squared cube root of xy. Now inspecting these three radicals right here, notice again that each one of them has the same radicand of xy, 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 and the indices are all 3. So these are all like radicals. Use a set of parentheses and put all the coefficients. This x squared comes down right here. This 3x squared comes down right here. And then finally, this negative xy squared comes down right in here inside the parentheses. All of these being multiplied by the common radical cube root of xy. Notice that there are some like terms here. X squared plus 3x squared gives me a 4x squared. And this one just comes down for the ride. Now these are terms in here, and these are not like terms because the exponent, well, this one doesn't have a factor of y. This one has 2 factors of y. So our final answer turns out to be, in parentheses, 4x squared minus xy squared all times the cube root of xy. So that's how you combine radicals. Remember, you can only combine like radicals. Whether you're adding or subtracting, you have to follow that rule.